right, so today we're going to talk about the cosine curve. The cosine curve is very similar to the sine curve. Really, what's all that's going to change is your little jingle here. It's going to shift the graph there, okay? So,
max,
good.
0, min, 0, max.
Yep, so rather than 0 max, 0 min, 0, we're going to have max 0, min 0, max. Okay? So when I'm graphing this, we still want to know what A and B are. Okay, so our amplitude, our amp is that's 1. Our B term, 1. Okay? Meaning we're going to see one cycle of this from 0 to 2 pi. So, everyone go ahead and sketch what you think the cycle looks like using our little jingle there.
Choose it on these.
Yep, do it on those. Do it on the graph paper. This is the first problem off your assignment tonight. Just do it on that graph paper.
What is that assignment?
I'll tell you. Okay. Hey, so good job. When I walked around, I saw that many of you did your max, your 0, your min, your 0, your max.
Oh, shoot.
Well done. Make sure it does not, I know that it kind of looks like a V, but make sure you curve it at the bottom. Okay, so it's not a V. All right, so there we've got it there. That is our cosine curve. In fact, this is the parent function, right? 1 and 1, so it's y equals cos theta. Now, if we actually graphed the sine curve, I'm going to graph it on the same graph. You don't have to. You can if you want. Put it in your notes, but you don't have to. So in blue here, we'll go y equals sine theta. Okay, and in this case, it's 0 max, 0 min, and 0. Good, yeah. And some of you'll notice right away that the graph is just,
it makes it all 3D unified.
yeah, it kind of makes it 3Dified for sure. It shifts it, right? Now, and here's the deal. Cosine means complement of sine. What's complement mean? Complementary.
Oh, isn't that like when two angles that add together to make 90 degrees?
Good. Together, yeah, 90 degrees. Complement of sine is the thing that'll make it 90 degrees. Okay, so in this case, this graph is shifted 90 degrees. If we were to figure our zeros for the cosine curve, well, this right here is out to 2 pi. We know that this line equals 2 pi. Okay? This line, halfway, is then pi, meaning this is pi over 2. Or if you're sketching the parent function, it's one complete revolution of the unit circle, right? So this is 3 pi over 2 right here. So when we shift, when we go from sine, y equals sine theta, y equals cosine theta, we're shifting 90 degrees. Pi over 2 is 90 degrees. Okay, that's all the cosine graph is. It's a 90 degree shift of the sine curve. Okay? So if you, for those that have kind of tried to tie this to your unit circle, we think of our unit circle. I'm trying to get a perfect circle. I feel like Donald Duck in Mathematically. I'm trying to make that perfect circle. There's like that point where he has a hard time. It's tough. So if you're thinking of your unit circle, and a lot of Trig, if you actually get Trig graphing paper, they'll have a unit circle, and they have the actual paper, the grid paper like this. But when we think of this, we start right here at 0, no matter which curve you're on, and then if you go to 90, 90 is right, well, first of all, this coordinate is 1, 0. 1 for cosine, 0 for sine, right? Okay? So 1 for cosine, 0 for sine. And then you get to here, and your coordinate now is 0, 1. 0 for cosine at 90, 1 for sine. Everyone with me? And then we move here, and we're now at negative 1, 0. Okay, and so this is 180, right? So pi. So we're at negative 1 on cosine, 0 on sine. Okay, and you go down here, we're at 0, negative 1. They're not after you, I promise. Okay? You got enough tinfoil around you to be good. Okay? Cheers. All right, so we get to here. Our cosine is 0. Sine is negative 1, and once again we get back here. Everyone see that? That's how our curve is working. Now we can figure out the stuff in between, but that's what's happening there. How many think you got it conceptually? You want to get pictures in your mind. It helps you out. That's why when you're like a baby, we didn't like read chapter books to you. You're like, hey, look, we're going to read this book, and you don't get to look at pictures. It's kind of lame. Some of you had chapter books read to you, I guess. That's kind of sad. Okay, Ariel. Harry Potter as a baby? Oh. Okay, everyone try number 2. Okay, moving on. Here we go. A is, what's our amp? 2. Amp is 2. B?
Pi.
B is pi. So what does that mean in terms of number of cycles?
Means you show 2 cycles.
Okay, Paul. Hey, B is the number of cycles, right? Brandon, what is how many is pi? Okay, but like numerically, what is it? Yeah, it's about 3.14. So how many cycles? About 3.14 cycles. Okay? That's about how many we're going to see, just over 3 cycles. Now, we still have to go out to 2 pi. So it would be helpful for us to know our period. Okay? Our period is 2 pi over b, which is 2. So in this case, 2 pi over pi, which is 2. So we're going the length of one of those cycles is going to be 2. And if you think about that, if we're going to see about 3 cycles, and the length of one is 2, that's 2, 4, 6. We need to get out to about 6.28, right? Okay, so here we go. We're going to start graphing it. We got our max, our 0, our min, our 0, our max. For some of you, it would be helpful if you actually stopped after that first cycle and labeled it and said, okay, I know this is a length of 2. That's the period length. Okay? And then 0, min, 0, max. I want you guys to know, by the way, while we're graphing this, I was talking to one of my subs the other day that I've had in the past, and he was raving about yours in 3rd period's class, about how amazing you guys are. I know. I told him you guys would say you know, but no, that's a good compliment when they'll. And I didn't even bring you guys up. He brought you guys up. So. It was a sub. I'm not going to tell you which one, but his name rhymes with Smickering. So. Well, that's a good sign. If you can't tell.
A good sign. Cosine.
Good cosine too, yeah.
We know. We know, baby. We know.
Okay, yeah, there's 6. We need to go.
Like half of a box down.
Yeah, like we need our zeros. If this is 6, this is 2, this is 1, this is. Yeah, that's 0.5 or a half. So each one's a half. So we got 1 half, 2 halves, 3 halves, 4 halves, 5 halves, 6 halves, 7 halves, 8 halves, 9 halves, 10 halves, 11 halves, and 12 halves, which is 6. Here is 13 halves. Now it was painful for Brooks last period to actually go to here. It just wasn't accurate, so we actually ended at 6.258 right there. Okay? We don't want to go too much further. Otherwise, we're making it painful for Brooks, and we don't want that.
And then we just draw 20 more cycles.
Brooks is in pain across the school.
Yes.
She's like, I can feel it.
Okay, questions.
Okay.
I feel like I'm losing us. Like, this stuff's way too easy for you. I haven't challenged you enough.
No, we're fine.
Okay, well, we're going to go one more. Number 4, and then I have to do a problem off yours. Another problem, like, that's not really graphing. So give 4 shots. Since we're amazing at this right now, let's go 30 seconds. You get 30 seconds to graph it.
So the jingle changes.
15. Dude, that was almost on the 30 seconds exactly. It's almost like I planned that.
Creepy.
Yeah, I didn't plan that. I'm going to pretend like I did. Makes me feel cool. All right. Okay, hey, this changed, right? Because it's negative. This actually becomes a min. This becomes a max. This becomes a min. How many got that? A lot of you had it. So this is 2 pi. This makes this pi, right?
Basically, you just don't start on 0.
Basically, you just, yeah. Basically. Pretty crazy. There it is. Bless you.
Pretty basic, basically.
So, hey, what this means, you guys remember the unit circle again? Let's sit and admire that circle for a second.
That is.
Pretty good, pretty close. Hey, if I'm going negative cos, and my first point is at -1 for cosine, remember x is -1, or, yeah, x is -1, right? You guys with me?
I'm looking.
All right, I lost some of you. All right, I don't want to lose anyone at this point. We'll come back to that. That's not even important right now. Okay, I don't want to lose anyone. Okay,
Maybe someone
hey,
we never found.
how many are with me right here? Okay, very good. I'll zoom in. Well, I'll zoom in as fast as it'll let me. Was that really fast? Really fast. Good? Okay, I want everyone to take a look at your assignment you grabbed on the way in. Take a look at number 17, please.
What side?
Big 1-7.
Example or mix?
Example side, number 17. This is another problem we'll be doing today. Okay, read the directions to yourself. Okay, so that would imply you will need a
Graphing calculator.
graphing calculator. Go ahead and take your graphing calculator out. Yes, I know.
Tron. Nobody laughs.
It wasn't funny.
Not even Zach commenting. I was hoping Zach would comment.
Oh, Plover.
No comment?
Look at Plover.
No. Okay.
Hayden, Okay.
Stop.
So,
If we make some tennis, I'm gonna die.
Hayden, take that off. Pay attention. Using the graphing calculator, solve each equation in the interval from 0 to 2 pi. So, I'm going to show you two different ways to do this. First, I'm going to point out how you do it by hand, which is kind of foreshadowing. In other words, I'm like presenting before you'll actually get there. I think that's what that means. Like an English term, right?
It is.
Very, very
It's hinting at the future.
multidisciplinary right there. Okay, so 2 sine theta minus 1 equals 0. Now, usually, what piece do we not see here? Have we not seen on this?
Theta.
Yeah. We haven't seen the equals 0. We also have another piece. Remember, equals 0 means equals y. It just means your x-intercept.
He's bummed.
Okay, so we could graph this and just see where our x-intercepts are, right? That's one way. So one way to think about it is to think of it like this. Plug that in. And that means we could go y sub 1 equals that. That's not how I'm going to do it. And you could figure and calculate your x-intercepts or your zeros.
Or you could graph it.
Okay? What's up? Yes, the negative 1 is another piece. So I'm going to ignore this piece right now. You could do this, but I'm not going to do that. All right? So, sorry, we got loud people out there. I see them dancing and stuff. Hold on, I got to... They look like Trig students, though. One is.
They're probably leadership.
Unbelievable.
That's because half the kids in leadership aren't actually leadership
All right.
quality.
Yes, they are.
They make posters.
Hey, they do a lot. Okay, we had technical difficulties there. Yeah. We won't talk about what we were talking about because... All right. All right. Hey, 2 sine theta minus 1 equals 0. As Ploger said, the negative 1's a piece that we usually don't see there. Now, we decided not to go this route. You could, though. If you wanted to put that into your calculator, calculate the x-intercepts or the zeros, that would work. Okay? I'm going to show you how to do this by hand. Usually we wouldn't have that 1 there. We'd bring it over to the other side. 2 sine theta equals 1. Add 1 to both sides. Okay, now from this point, we could keep going. If we're going to do this by hand, we'd actually keep getting sine theta by itself. Okay, if we're going to use our calculator, we may stop here and use it again. Okay, but I'm going to get sine theta by itself. How do I do that? Divide by 2. So sine theta equals 1/2. Now, some of you that are really up on this, you could start thinking about the unit circle that we made you use so many times. Okay? And you could start going, hey, sine equals 1/2. Where does my sine theta, or the sine of my angle, equal 1/2? Think to yourself on your own, where does sine equal 1/2? Okay, where's sine 1/2? Think of coordinates. Yep. It is not at pi. Yeah? No. No. Hold on. Hold on. Sine is what? X or Y?
Y.
It is Y. This is cos. This is sine. Where is my coordinate? 1/2. It is not at 45. Yes. 30 degrees. Yes. Now, if there are those of you who couldn't answer that, you need to memorize your unit circle again. Okay? 1/2. Where else is sine 1/2? Hint. Hint. Okay, right. Well, that would be nice if it was more of a horizontal, but right there, which is
150.
150. It's 30 from 180, right? It's 150 degrees.
210.
Now, so we have at 30 degrees, So if you're doing this by hand, this would be your answer. My answer would be 150, which we usually don't go into degrees. We go into radians. What is 30 as radians? Pi over 6. What is 150 in radians?
5 pi over 6.
5 pi over 6. Good. Pi over 6, and then 5 pi over 6. So our answers will be that and that. Those are actually our solutions. Now, let's actually use our calculator like they've told us to do this. Because some of them won't be that easy. That was so easy. Okay? Let's think of this as y sub 1. And let's think of this as y sub 2. So one way to use our calculator is to actually set sine theta equal to y. Y equals sine theta. And we're calling it y sub 1. And set 1/2 equal to y. You can do this with any equation. Like back in the day when you're solving 4x plus 2 equals 3, you could have done it there. Okay, thank you. And so y sub 2 will be 1/2. And then we graph them. So on your calculator, I want you to put both of those in and graph. Okay, remember, theta is going to show up as x. Now, some of you are going to get some messed up looking graphs unless you actually change a few things around here. Okay, so for instance, measure in radians, since that's what we're going to calculate our answer in. Let's go radians. So go to mode and make sure you're in radians. Second thing is you may want to reset your window. So remember, when you're dealing with 0 to 2 pi for the x, you'd actually want to set your window from, go x min at 0, right? Because we graph from 0 to 2 pi. They're actually telling us in the directions. Find the answers from 0 to 2 pi. Solve each equation from 0 to 2 pi. So x is 0, y, or x max is 2 pi. So when you put in your 2 pi, you get 6.28. Okay, I'm going to go up by 1. It really won't matter on the scale right now. Min, I'm going to make 2 and negative 2 just because of the 2 in front. I know that's my amplitude. Okay, and so when I hit graph, I get that looking thing. Then there'll actually be another little piece that goes through. See that? What is this?
So y equals 1/2.
Well done, Ploger, man. Y equals 1/2. And how many solutions are there?
2.
2. There's this one and this one. So we're going to calculate those. So we go to second, trace, or calculate. What are we calculating? Intersect. Okay. And so it says first curve. Well, is this my first curve? Sure. We'll go with that. Second curve. Is that my second curve? Sure. It says guess. In other words, put your cursor next to the 0 you want to, or not to the 0, but the intersect you want to calculate. So it's going to calculate this one since the cursor's right there. Okay? So we hit enter, and it tells us our answer is?
0.523.
Are we solving for x or y?
Oh, that's not the one I got.
Solving for x or y?
X.
X. Theta's x, right? 0.5 is the 1/2. Okay, so our solution is 2.62-ish. So theta equals approximately 2.62. Everyone with me? Okay, let's calculate the other one. Anyone calculate it yet?
Yeah.
What'd you get?
0.52.
0.52. So you had to move your cursor close. Well, here's the problem I have, and some of the students that I don't know, maybe you're thinking this yourself. Like I said, the answers were these, and now I'm telling you the answers are these.
Same thing.
How are they the same thing?
Pi divided by 6 equals 0.52.
Okay, so if we actually clear out here and we go pi divided by 6.
3.14 divided by 6.
The exact answer I got.
0.52. Nice. And so if we go 5 pi divided by 6, we better get 2.62. Yeah, dude.
It's magic.
Yeah, it is magic. Hey, we'll be solving equations like these later on in the year. This is how you do it using your calculator. Now remember, you could have done it right here if you wanted to. You could have just calculated the x-intercepts. Okay? So while you guys are looking at your assignment right now, 1 through 22 is what you're completing today. Okay? No, don't cross out the bottom because the bottom says what? What type of graphs are those? Tangent. Woo-hoo-hoo.
That will be
Yeah.
Monday. Monday, huh?
Yeah. It's awesome. Hey, by the way, if you would have, guys, if we would have just calculated the intercept, plugged this in, the original equation they gave us, since it was equal to 0, and then just hit graph and calculated the intercepts, it would have given, or the zeros, it would have given you those exact same 2 points. That's fine also. Think about how much you just learned right here, though. Aren't you happy?
I'm happy.
I'm happy.
That's fine, though.
Quick